In the year 2011, the world watched in suspense as Japan was rocked by a devastating earthquake and tsunami. But amidst this catastrophe, something strange happened. A loud ringing noise was heard across the country. It sounded like an air raid siren, but it wasn't. It was the sound of earthquake alarms. This advanced warning system gave people precious seconds to seek cover before the full force of the quake hit. Now imagine if such a system existed globally. If the Earth could send out an audible alarm before rumbling, would it be possible to predict earthquakes accurately? What if we could hear the Earth growl before it unleashed its fury, giving us time to prepare for the tremors? Today, let's delve into this fascinating idea and explore whether such a global earthquake alarm is a reality or a distant possibility. Quakes don't roar, they grumble. Before an earthquake strikes, the ground often emits a low humming sound known as an earthquake alarm. The sound is produced by the sudden release of energy in the Earth's crust, which causes seismic waves to travel through the rocks and soil. These waves create a variety of noises, including the familiar rumbling and crashing of the main shock and the less noticeable but equally important signals of an impending event. In fact, these precursory rumblings have been reported throughout history. In ancient China, for example, people described hearing strange sounds in the days leading up to a major earthquake. But it wasn't until the 20th century that scientists began to take these accounts seriously. Today, researchers are actively listening to the Earth's grumbles in an effort to develop early warning systems for earthquakes. In recent years, there has been a lot of talk about the potential use of AI to predict earthquakes. The idea is that by analyzing data from various sources, such as seismic sensors and GPS stations, AI could identify patterns and anomalies that indicate an impending earthquake. One promising development in this area is the use of machine learning algorithms to detect subtle changes in the Earth's acoustic emissions. By listening to the constant hum of the Earth and analyzing the signals, AI could potentially identify the precursors of an earthquake and issue an alert before the event occurs. While this technology is still in the experimental stages, it holds great promise for the future. The concept of an earthquake alarm is not new. In fact, many countries around the world, including Japan and China, already have systems in place that emit loud noises or other alerts when an earthquake is detected. However, these systems typically only give people a few seconds of warning, which is not enough time to take cover and protect oneself from the potential damage caused by the quake. To truly be effective, an earthquake alarm system needs to be able to warn people far enough in advance so that they can take appropriate action. And while predicting earthquakes is notoriously difficult, recent advances in technology may finally make it possible. One approach that has shown some success is using machine learning algorithms to analyze data from a variety of sources, including seismic sensors, GPS stations, and even social media posts. By identifying patterns and anomalies in this data, algorithms can potentially forecast the likelihood of an earthquake occurring in a given area over a specific period. This information can then be used to issue timely and accurate alerts to the public, giving people time to take cover and potentially saving lives. Another promising approach is the use of satellite-based systems to monitor the Earth's surface for signs of stress and strain that could lead to an earthquake. By measuring changes in the Earth's gravitational field, satellites can detect the movement of underground fault lines and provide valuable data for earthquake prediction. This information can then be used to issue alerts and warnings to those living in at-risk areas. But even if we had the technology to accurately predict earthquakes, there are other challenges to consider. For example, how would we communicate the alert to people in a way that is both effective and timely? Would it be through sirens, mobile phone alerts, or television broadcasts? And how would we decide who to alert and when? These are complex questions that require careful consideration. The idea of a global earthquake alarm is a fascinating one, but it's also a daunting challenge. While the technology to predict earthquakes is rapidly advancing, there are still many obstacles to overcome before we can have an effective and reliable system in place. Nevertheless, the potential benefits of such a system are enormous. The ability to give people even a few minutes of warning before an earthquake could save countless lives and reduce the damage to property and infrastructure. As technology continues to improve, we may one day have earthquake alarms that sound like a familiar song, alerting us to danger and giving us the time we need to take cover. But what if the Earth's rumblings could be heard not just in the immediate vicinity of an earthquake, but all over the world? Would this amplify the sound to a level that could be detected by humans? The answer is yes. In fact, the sound of an earthquake can travel around the globe and be picked up by sensitive enough microphones. This phenomenon is known as a seismic roar, and it occurs because the energy released by an earthquake can generate sound waves that propagate through the Earth's crust and atmosphere. These waves can travel thousands of kilometers and have been recorded by networks of seismic stations around the world. But the question remains, could we develop a system that uses the Earth's seismic roars to provide global earthquake alerts? The idea is intriguing, but it faces several challenges. First, the sound of an earthquake can be masked by other noises, particularly in densely populated areas. This means that a global earthquake alarm system would need to have very sensitive microphones to pick up the faint rumble of an earthquake amidst the background noise. Another challenge is that the sound of an earthquake varies depending on the location and magnitude of the event. This means that a global system would need to be able to identify earthquakes of different sizes and depths, as well as those that occur in different geological settings. Despite these challenges, the idea of a global earthquake alarm is worth pursuing. In recent years, several research groups have made significant strides in this area. For example, a team of scientists at the California Institute of Technology has developed a system that uses a network of seismic stations to detect the initial seismic waves of an earthquake. This information is then used to generate an alert that is sent to local authorities and the public through various channels such as mobile phone apps and social media. Another promising development has come from the University of Cambridge, where researchers have developed a system that uses a network of low-cost sensors placed on buildings to detect the early stages of an earthquake and issue an alert within seconds. These advancements bring us closer to the day when a global earthquake alarm system could become a reality. Such a system would undoubtedly save countless lives and reduce the damage caused by earthquakes around the world. Imagine receiving a gentle warning before the earth begins to shake, giving you time to take cover and protect yourself and your loved ones. While the technology to do this is still under development, the progress being made is nothing short of remarkable. As we continue to explore and understand the inner workings of our planet, we may one day unlock the secrets of the Earth's rumblings and harness them to save lives and protect our communities. Perhaps one day, in the not-too-distant future, we will have an advanced global warning system that gives us a heads-up before the Earth starts to rumble and shake. Maybe it will sound like a siren or a bell, a signal that tells us to drop, cover, and hold on tight until the tremors pass. Or maybe it will be a vibration that we feel in our phones, a quick buzz that lets us know to take cover. Whatever form it takes, this warning could mean the difference between life and death for many people around the world. It's hard to say exactly how long it will take to develop and implement such a system. After all, predicting earthquakes is one of the most challenging problems in science. But it's a goal that many experts believe is within reach in the next few decades. With advances in technology and a better understanding of the forces that shape our planet, we are getting closer and closer to the day when earthquakes don't catch us off guard.